What is titration? It is the slow addition of one solution, known concentration, called a titrant, to a known volume of another solution of a known concentration until the reaction reaches neutralization, which is often indicated by a color. As a base indicator are weak organic acids that change color depending on the pH of the solution. It is a compound added on a small amount so the pH solution can be determined visually. The indicator causes the color to change depending on the pH of the solution. pH value used to indicate the acidic or basic or neutral character of the substance you are testing. We begin the experiment by preparing the materials needed. Approximately 2 tablespoons each of the substances into their designated cups. For water, baking powder, vinegar, sugar, bleach, Sprite, calamansi extract or calamansi juice. We added 1/4 cup of water in each cup. In order to be able to mix the kamote tops extract properly with the solutions. Add the kamote top extract to the solutions by filling up the cup till half. Color change of each of the solutions. Rearrange the solutions according to their pH. Start from the left with the most basic to the right with the most acidic. The solutions resulted in varying color changes upon addition of the kamote top extract. The solutions resulted in varying color changes upon addition of the kamote top extract. The solutions resulted in varying color changes upon addition color of a red, while the calamansi juice turns into a pink color change, and the vinegar turns into a light pink color change. Last but not the least is the bleach, which turns out to a light color change. The kamote top extracts have acidic solutions to a color ranging from light pink to dark red. Changes basic solutions, a color ranging from light green to dark green.
You carefully add the known solution to a set volume of the unknown solution until the reaction is complete. This enables you to work out the concentration of the unknown solution. You may need to use an indicator to signal the end of the reaction. You can calculate the concentration of an acid or an alkali by carrying out a titration experiment. In this video, we are going to look at how to carry out titrations. In the next video, we will then look at the calculations to go with the experiment. The apparatus needed for titrations looks like this. The pipette is used to accurately measure a certain volume of the unknown solution into the flask. The burette is then used to accurately measure and add the known reactant to the unknown until the reaction is complete. The burette can measure up to a 0.05 cubic centimeter accuracy. To carry out a titration, you follow these steps. 1. Using the pipette, add a set volume of the unknown solution to a clean conical flask. 2. You may also need to add a few drops of indicator. 3. Fill the burette with the known solution and make sure it is leveled off at exactly 0. 4. Slowly add the solution from the burette to the unknown solution in the conical flask. 5. You may need to swirl the flask to mix or use a stir plate. 6. Stop adding when the reaction is complete or the endpoint is reached. This is where an indicator may help you because there would be an appropriate color change. 7. Record the final volume on the burette. This gives you the volume of the solution added. This volume is called the titer. 8. For an accurate experiment, you should repeat this experiment a few times until you get consistent values for the titer. Depending on the indicator you use, the color change will be either gradual or sudden. If you are carrying out an acid-alkali titration, you may use universal indicator, which would give a gradual color change. Though this might not be ideal because of this gradual color change. Litmus gives a sudden color change. But there are other better indicators that are specialized for the acids and the alkalis in the titration. Sometimes the acid may be the known solution and the alkali unknown, and other times the alkali the known and the acid the unknown.
Precisely neutralizing it with an acid or base of known concentration. So let us quantitatively know now the concentration of the unknown solution.